Okay, good morning children. So today we are going with physics and the name of the chapter is sources of energy. So I told you many times what are energy, what is energy. So how many sources of energy are there? From where we are getting energy is the main thing here. So sources means the thing from where we are getting the energy. We will get energy through many things. It may be wind energy, it may be electrical energy, it may be thermo energy, or it may be any kind of different types of energies. But here the main thing is how we will get these energies and what are the type of energies are there. So what is the importance of these energies and how these energies are transformed from one form to another form. I told you already we have a law of conservation of energy also. What is law of conservation of energy says is the law of conservation of energy I told you already in the beginning itself only. So what is saying here is, so in 9th standard we have studied in detail, so we will not go there in detail in 9th standard what we have studied here. So we will come to that directly to 10th standard. So what is a good source of energy? See, energy we will get through many different kinds of things. So which will be the good source to get the energy is the main important thing here. So from where we will get the good source of energy? So there are many things from where we will get the good sources of energy. We have different types of there. It is given one by one here. So we have how much heat does it release on burning? Does it produce a lot of smoke? Is it easily available? The factors here. And we could then say that a good source of energy would be one. Which one we will say as a good source of energy? He has given there. So which could do a large amount of work per unit, volume or mass, be easily accessible, be easy to store and transport, and perhaps most importantly be commercial. But perhaps most importantly be commercial in the sense it should be used for commercial purposes only. Commercial purposes in the sense it may be in the home, in the industries or any different types of factories, whatever we are using today, the conventional sources of energy. So here you have the conventional sources of energies from where we will get different types of energies. He has given there, so from where we are getting the energies, in generally the first thing is coal. From coal we are getting a lot of energy here, and second we have petroleum and natural gas, and third we have hydro. Hydro means water, and nuclear energy, it is one of the best energy today we are getting, but we have both here. We have nuclear fission and nuclear fusion and nuclear fission. One is controllable and another one is not controllable, but it is a risky one, but it is the most suitable way to get the energy. Nowadays many countries are going with this nuclear energy only, and we have wind energy also. So I think you might have saw windmills there. So from there also we are getting energy. And the first form of energy is given fossil fuels. What are fossil fuels? Generally, fossils means the remaining of different types of animals. Maybe it may be dinosaurs, or it may be any sort of things, or it may be animals. Whatever it is the fossils. Nearly for imagine, think about before 3000 or 4000 years back when there was volcano eruption was there. These animals have been trapped in the ground there, and now those fossils we are getting in the form of energy. In the form of energy means how it may be in the form of petrol, it may be in the form of diesel. So then again purification you will get kerosene. So whatever it is. So fossils, from the fossils we are getting the different kinds of energies here. He has given in this also. So burning fossil fuels has other disadvantages also, but both advantages and disadvantages also, because there is a lot of release of carbon dioxide in this process in fossil fuels. The pollution caused by burning fossil fuels can be somewhat reduced by increasing the efficiency of the combustion process. Combustion process means what is maybe combustion? Combustion means it is a process where we will do combustion in the presence of oxygen. We will burn something in the presence of oxygen is a combustion process. So this type of energies we will use generally to produce electricity, and different types of energies also out there. Is given the activities, that activities it will be done here. He has given one example here. A model to demonstrate the process of thermoelectric production. So thermoelectric production, I told you, I gave the example of dynamo. Nowadays, for the best example is cycle. We used to have dynamos. Now we don't have, but when we are small, when we go to 20 to 30 years back, the cycles which we used to run, they used to have the lights also. I explained to you also how these things will run. They run on the basis of dynamos only. So there the mechanical energy is converted into light energy. He is given a simple example here, but don't do this one. It should be done in the presence of other teachers or any expert persons. So he has given the pressure cooker and the turbine. When the pressure starts coming out, that pressure is made to rotate the turbine. When the turbine rotates, it is connected to the dynamo. Then the dynamo converts this energy into light energy. That's what we see in the cycles nowadays. So when we start pedaling the cycle, so mechanical energy will be converted into light energy here. We have thermal power plant also. Large amount of fossil fuels are burnt every day in power stations to heat up water to produce steam, which further runs the turbine to generate electricity. Main thing, whatever you do to produce electricity is to make the turbines to run. If the turbines runs, then only you will get the electricity. So the procedures are different here. The procedures may be different from one section to another section on which the turbines we start rotating the turbines here. So when you start rotating the turbines here, automatically when the turbines rotate, the electricity will be produced. That's what we have here, thermal here. The transformation of electricity is more efficient than transporting coal or petroleum over the same distance. Therefore, many thermal power plants are set up near coal or oil fields. The term thermal power plant is used since fuel is burned to produce heat energy, which is converted into electric energy. Thermal means temperature, which is heat energy, that is converted into electric energy. And we have hydro power plants. Hydro power plant means, hydro means I told you already, it is water. So water power plants we have. So another traditional source of energy was kinetic energy. I told you what I mean by kinetic energy also. The energy that the body possesses because of its motion is called kinetic energy. And we have potential energy also. What is potential energy? The energy that the body possesses because of its position is called potential energy also. So two types of energy, kinetic energy and potential energy. So in hydropower plants, generally if you take hydropower plants, means if you take big dams, for example, if you take our own dam, Tungabhadra dam only, when the water falls, the main intention is making the water to fall on the turbines. I told you already. The main part of the producing energy or electricity is here, making the turbines to rotate. So here what we are doing, we are making the turbines to rotate by leaving the water. When the water flows from the dam, directly the water falls on the turbines and the turbine starts rotating. When these turbines starts rotating, automatically the energy will be produced through electromagnetic induction. That is very important. So we are not taking anything here. Just we are making the water to fall, turbines run. When the turbines run, in the electromagnetic induction, what I told, same thing will happen. When a magnet is passed through a electrical circuit in the sense which is the coil which is present there, then electricity is produced. He has given some example for this also. Systematic view of hydropower plant is given. See, the main thing here is slice gates are there. What he is doing is here, he is making the turbines to rotate. If the turbines rotate, then the remaining water is left to the river. Improvements in the technology for using conventional sources of energy. We have biomass. What is biomass? Biomass is nothing. Bio means the things which have life. So by taking that, we are producing different types of energies here. So we have, you must be familiar with the use of cow dung cakes as fuel. Cow dung means ಕನ್ನಡದಲ್ಲಿ ನಾವು ಸಗಣಿ ಅಂತ ಕರಿತೀವಿ. ಮೊದಲೆಲ್ಲ ಏನು ಮಾಡ್ತಿದ್ರು, ಸಗಣಿಯಿಂದ ಎಣ್ಣೆ ಮಾಡಿ ಅದರಿಂದ ಸುಟ್ಟು ಫ್ಯೂಲ್ ಮಾಡ್ತಿದ್ರು, cow dung ಯೂಸ್ ಮಾಡ್ತಿದ್ರು. So we have different types of also, and technological inputs, improvement of efficiency, which are the facts which are necessary for the improvement in our product. And we have cow dung, various plant materials like the residue after harvesting the crops. When the crops are harvested, we will remove the crops and that crops can be converted. And we have vegetable waste, sewage are decomposed in the absence of oxygen to give biogas. And this is sewage means the drainage water which will present there, that water along with that waste it can be produced. That also, since the starting material is mainly cow dung, it is properly known as gobar gas. Gobar in Hindi, generally the word gobar is in Hindi. Gobar means cow dung. Cow dung is gobar andre ಕನ್ನಡದಲ್ಲಿ ನಾವು ಸಗಣಿ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಗೋಬರ್ ಗ್ಯಾಸ್ ಅಂತಂದರೆ ಸಗಣಿಯಿಂದ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡೋ ಗ್ಯಾಸ್. ಅಂದರೆ ಜನರಲಾಗಿ ವಿ won't use their cow dung. It is the main thing there. Along with the cow dung we use different types of vegetable waste and materials so that it will be used and processed there, and there from there we'll get the energy. That is the cow dung energy. He has given the systematic diagram of biogas plant there. You can see there. So biogas is an excellent fuel as it contains up to 75% of methane. Underline the word methane. I told you what is methane. Methane is C2H. Methane is also called as methyl alcohol. So methyl alcohol, C2H4, sorry, not C2H, CH4OH. And C2H5OH is ethane. It is ethyl alcohol. Okay, it is called as ethyl alcohol. So this is how they are producing the methane. It burns without smoke. Methane leaves no residue like ash in the wood. So within the just carbon compounds, we will not get more carbon compounds here. It is heating capacity is high. Biogas is also used for lighting. The slurry left behind is removed periodically and used as excellent manure. So the waste can be used as manure. Use ಮಾಡಬಹುದು. Rich in nitrogen and phosphorus, the large-scale utilization of biowaste and sewage material provides a safe and efficient method of waste disposal besides supplying energy and manure. See, and next we have wind energy. I think you are familiar with wind energy. So we have windmills everywhere nowadays. We can see a lot of windmills. The main thing is the highest windmills what we have nowadays is in Kanyakumari. The highest way, we will get one more question also. So the highest windmills are present in Kanyakumari. So from windmills we are getting more energy also. So in windmills the same process. When the wind blows, the turbines will start, or the wind fans what we call, they start rotating. When they start rotating, they make the turbines to rotate. When the turbines start to rotate, automatically the energy will be produced. That is nothing but electrical energy. Here we are not using anything. Everything we are getting from the nature. Since we are getting everything from the nature, so there is no problem in doing these type of things. So we have alternative source of non-conventional sources of energy. With the technological process, our demand for energy increases day by day. Our lifestyle is also changing. We use machines to do more and more of our tasks. Our basic requirements also increasing as industrialization improves our living standards. So today we are wasting a lot of energies also. I told you all the 100% of energy is not converted to 100% of energy totally. If you take 100% of light energy, 100% of light energy is not converted to 100% of light energy. So what is happening here? Only 60 to 70% is converted into other forms of energy, and the remaining will be in the form of heat energy or any different kinds of energies. That way we are wasting more. So what we are using the energy, it is not totally converted into other forms of energy, exactly what we are supposed to do. That is it. And you are familiar with solar energy. Solar energy means, solar means what? So solar system, you know, so that is the sun. So we are getting energy from the sun also. So today nowadays we are going more with solar panels. He has given the example here also. The sun has been radiating an enormous amount of energy at the present rate of nearly 5 billion years, and will continue radiating at the rate for about 5 billion years more. See how much energy it is getting. But the thing is, we are unable to take exactly what we are getting from the sun, 100% of energy. So today also we are not in such a condition where we can use the 100% of energy of the sun. So we are using some only 10 to 15, 20, 30% of solar energy that is possible here. He has given one example also, and he has solar panels and solar lights also there. Nowadays in streets also you get solar lights also, street lights and everything. Cooking also through solar, and everything is now we are getting with solar. We have solar heaters and everything also. Now let us see energy from the sea. So getting energies from the sea, we have one is tidal energy. Tidal energy is the energy that we get from through tides. Tides in the sense the waves what we are getting there. So from that also we will get energy. And waves energy, the waves also through waves we are getting different energies also. Waves in the sense how the waves run, whether it is whether they are fast or slow. It is a critical one for the time being. You remember that we are getting from tides and we are getting from waves, and also ocean thermal energy. The temperature which is present in the ocean, from that also you can extract the energy. That is a large process, but the main thing is from ocean also we are getting thermal energy. And geothermal energy, that is also from geo, that is from the earth we are getting the temperature. From that temperature also we can get energy also. And most important thing is nuclear energy. I told you nuclear energy is very important one, because nowadays many other countries are going familiar with this nuclear energy also. But the thing is, the getting of uranium, plutonium and radium, these type of things will be used in nuclear energy, which are very hazardous. But the thing is, if it is in a control condition, it is well and good. If it is not in a control condition, then it is very difficult with this nuclear energy. The major hazard of nuclear power generation is storage and disposal of spent up used fuels. So what you are spending and what you are releasing is also very important. That is also not useful, because the disposal of these waste are very dangerous. Directly we cannot release them into the oceans, which are very dangerous also. Nuclear energy was first used for destructive purposes before nuclear power stations were designed. Generally we used to use for bombs, preparation of bombs for destructive. Destructive means when there is a war we used to go for nuclear bombs and things, but nowadays we are using it for purpose of production of electricity. I told you we have two types of nuclear energies which can be controlled here. One is nuclear fusion and nuclear fission. So we have environmental consequences. So what will be the hazards when we are going with these different kinds of energies there? So we have studied various sources of energy in the previous sections. Exploiting any source of energy disturbs the environment in some way or the other in any given situation. The source we would choose depends on factors such as ease of extracting energy from the source, and also we have CNG, clean fuels like CNG. It would be more extract to say that the particular source is cleaner than the other, that it will be there. For example, if you have cylinders in your home, you may get one blue color flame or red color flame. So depends upon whether the combustion is fully used or not. If the combustion is fully, you get a blue flame. If the combustion is not complete, then you get the yellow flame there. I told you, I explained this also many times. How long will the energy source last us? So we are using all different kinds of energy: tidal energy, wave energy, solar energy, wind energy, thermal energy, geothermal energy. These type of energies we are using. So for how many days we can use these type of energies? For 1 year, 2 years, 100 years, 200 years. So yes, given. So renewable energy is available in our natural environment in the form of some continuing or repetitive currents of energy, or is stored in such large underground reservoirs that the rate of depletion of energy reservoir because of extraction of usable energy is practically negligible. So overall what you want to say is, whatever the energy we are using, it is useful, but at the same time we are wasting a lot of energies also. I told you law of conservation of energy also. So what does it say? Energy can neither be created nor destroyed, but can be changed into one form to another form. So we can change the energy into one form to another form, but we can never create the energy. So if you want to create the energy, it is very difficult to create the energy. So we cannot create it, but can be transformed into one form to another form of energies. Okay, children? So today up to here we'll stop it. So in the next class we'll continue the same chapter. I think chapter is over, and everything which I given here, you can take these things from the study material which I have sent there. So from the study material you can go there and you can go with what I have explained there, what is given there, and notes which is given there in the textbook or in the notes there in your mobiles. Okay, in Telegram it has been sent already. You go there and you start writing the notes there according to the basis which has given. It has given very clearly how it is used and on what forms it has used, and go through it point wise. I told you to write as in point wise. Don't go with the paragraphs. Write with paragraphs. Okay. Thank you, children.